So what you're looking at is a complete breakdown of every decision my local AI agent is made before answering a single question. Each node, read input, analyze code, check quality, and the final answer represent a specific stages in the reasoning process. Every step is logged automatically with a timestamp, token usage, and more. And if you open any step, you can see the model exact response. In this case, agent is asking the model to review its own evaluation, and the model replied confident enough to proceed. And if you go one layer deeper, you will see the raw system prompt and the exact human response word for word. This level of transparency doesn't exist in ChatGPT or Claude. Normally, the entire reasoning process is a black box until now. And the output, SQL injection detected, missing error handling, performance bottleneck. All valid issues with the correct fixes. And this is the same Python broken project that caused hallucination in our previous video. All this is running locally, free model and free tools. So by the end of this video, you will be able to build a local agent that can review your code, and more importantly, you can see the agent is actually making decisions under the hood. So let's get into it. Alright, in the previous video, we explored Claude Code running locally with LM Studio. It could read file, find bugs, and write fixes, completely free. And we also look at LM Studio to understand the hardware layer, tokens, checkpoints, batch processing. But those logs tell you what the model is computing. They don't explain the decision layer. For example, why did that agent read that particular file? Why did it decide to retry? How confident was it at each step? Those answers were still hidden from the user. So today, we are going deeper, fully unpacking the agent layer and understand how these systems actually make decisions. Alright, before we go deeper, let me quickly introduce 3 tools we'll be working with. First, LangChain, the most widely used framework for building AI applications. Its job is simple: connect your code with the AI model. OpenAI, Anthropic, or in our case, local model running inside the LM Studio. So instead of writing messy API calls, LangChain manages all the communication for you. Next, LangGraph, built on top of LangChain. And this is where things get really interesting. So instead of single AI calls that gives a single answers, LangGraph let you build the entire workflow, multiple steps, branching logic, decision point, and even loops, where the agents can retry if it is not confident. That's what makes an agent not just a chatbot. Then finally, LangSmith, the observability layer. This is a tool I'm excited about. LangSmith records every action your agent takes, every node, every model call, every token, every decision. There is even a free tier, and this is exactly what you saw in the intro, the full execution trace of the agent reasoning. Great, now you understand all the tools. Let's see how these fit together. At the center, you have the agent.py, the brain of the system. This is where all the decisions are made. Inside it, 2 things are running. LangChain, it handles the communication with the model. LangGraph, define the workflow with our 4 nodes: read input, analyze node, check quality, and the final answer. The LangGraph also manages the state, shared memory across nodes, and the decision loop, the part that decides whether the agent should retry, revise, or move forward. On the left, you have the LM Studio running our local model. So whenever the node requires the actual reasoning, LangChain sends the prompt to the LM Studio. The model processes it and the response comes back. On the right, you can see LangSmith, one-way arrow, login only. Every time a node runs, every time the model is called, a complete trace is sent to the LangSmith. It never sent anything back. It only records what happened. At the bottom is the input. For example, is the code production ready? The question enters agent.py, follow through the nodes, hit the model as needed, loop if confidence is low, and finally produce an answer. And here is a key point. Everything on the left is 100% local. Your machine, your model, your data. Everything on the right is observability. If you remove the LangSmith entirely, the agent still works and you simply lose the trace view. Alright, now we understand how the agent works. So let me demonstrate how to set this up from the scratch. So I'm using Windows machine. So first let's create a new project folder and initialize the Python virtual environment. Let's activate it and make sure that you are running the recent Python version. Next, couple of packages we need. LangGraph, the state machine. LangChain-OpenAI for the model interface. LangChain-core for the message schemas. Then Python-.env for handling the environment variables. Alright, let's see how to set up the dashboard. For this, let's go to smith.langchain.com. This is the observability layer. For the first time login, create an account which is completely free. Then go to the settings and create new API key. Choose personal access token. We'll set up the default workspace and set expiry if you want. That's pretty much we need to do right now here. Alright, let's copy this key and we'll create an environment file on the terminal. So let's create .env file and add these 5 variables. The LangChain variables are for enabling the traces, the OpenAI variables to make the LangChain talk to the local model through LM Studio instead of Claude. Finally, let's launch the LM Studio. I'm using Quen 3.5 2 billion parameter model, same one we have used in our previous video. Leave the context window at 4096, which is the default one. Make sure that local server is running, otherwise the LangChain will not able to connect. Great, that's a simple automation stack we are going to use in this video. Now we'll jump into the actual agent logic. Alright, here is the important part, the agent code. The structure is simple, 4 functions wired together inside a LangGraph workflow. So we start with import and connect to the LM Studio. Even though we use chat OpenAI, we just point to the base URL to our local endpoint. Temperature is set to 0.1 for consistent code reviews. And we load Quen 3.5 2 billion model with a 2k token cap. At the line number 25, we define agent state, the shared memory for the whole graph. It stores the code, questions, last analysis, confidence scores, and retry count. So this is how the agent remembers what happened to the previous tab. Alright, now comes to the nodes. So we have set up 4 nodes here. First one is read input, which basically pass the incoming questions and reset the counters. No AI call happens here. Now comes to the node 2, which analyzes the code, starting from the line 46. This is the main reasoning step. So on the first attempt, it does a general review. Now here is a case, if the retry loop is there, then it do a stricter prompt focusing on SQL injection, error handling and performance issues. And on the node 3, it checks the quality by sending the analysis back to the model and ask for a self score between 0 to 1. This is how the AI judges its own work. Then comes to the final answer block, which packages everything into a clean summary. Now let's talk about the routing logic, which basically do a checks on the confidence score. So if the score is greater than 0.7, then it is done. And if it go below, a retry attempt is made. And if retries hit 3 times, it stop looping. Now in the section 5, this is very interesting. This is where all the nodes are getting wired into state graph. So if should underscore try returns retry, then we loop back to the analysis node. If it is done, then it goes to the final answer block. And finally, on the line number 194, we run the test using the same broken code from our previous video. SQL injection, no error handling, nested loop, 4 functions, 6 bugs. App.invoke pushes the input through the graph. If the confidence is low, the graph automatically triggers retries, no manual work. Alright, that's pretty much our agent code. This is around 250 lines, including our test code. So let's run it using Python. Alright, let's go ahead and run this one, python agent.py. And immediately you can see node 1 fires up, read input. No AI call here, just picking up the questions and logging it. Then the node 2 kicks in, which is analyze node. If you jump over to LM Studio real quick, you can see right there the request came in, tokens are being processed. So that tells us the model is actually working on it right now. Now what's really cool here is that we don't need to go and create anything in the LangSmith. The moment our code starts, if you look at the tracing section, a task just popped up automatically. So let's go ahead and click on that. And look at this, the full execution trace is building right in front of us. So let's walk through each one. So first up, read input. If you click on it, you will notice every nodes give you an input and output tab. On input side, we got our broken code sitting right here. And then our questions, is this Python code production ready? And there is no output here, which makes sense because this node is basically just passing things forward to the next step. Okay, now analyze code. This is where things start really interesting. Same input flows from the read input, but this time node actually make an AI call. If you click on that call, you can see 2 important things here. First one, the system prompt. You are the senior code reviewer. Be thorough and specific. Then the second one, the user message. Review this Python code for issues, list every bugs, security issues and bad practices. And all of this coming directly from our agent code, getting sent straight to the local model. And if you quickly hop back to the LM Studio, you can see all these tokens are flying through. So that's basically this exact call happening in real time. Alright, look at the node 3 just wrapped up. Check quality is done on the first attempt. Let's see what LangSmith actually captured here. So if you look at the output from the analyze code AI call, the result actually really solid. It says comprehensive review, critical security vulnerabilities found, logical flaws, bad practices across all the function. It is listing out every single issues. Then at the bottom you got a full summary of the fix, suggestions and the actual code reference, which is honestly excellent for a local model. Now here is where it gets really interesting. On node 3, check quality. So what's happening here is that agent takes its own analysis and send it back to the model, basically asking how good was my review, score between 0 to 1. That's why if you look at the input, the confidence start at 0. And look at this AI call, rate the quality of this code review on the scale of 0 to 1. And it gives specific criteria too. Did you find the issues with the reference? Did you catch the performance problem? And things like that. And the output comes back with 1, so the model is saying, yeah, it's fully confident in this review. Then the should underscore retry runs, which is just our Python logic, no AI involved. It checks our score against a 0.7 threshold. And the output says done, no retry needed, and move forward. And finally we hit the last node, final answer. So basically what happens here is a full analysis get packaged up and sent to the model one more time. With the system prompt, give a clear actionable code review summary, and the user prompt saying, based on your analysis, give me a structured final answer. And if you look at the output, it's beautiful, perfectly formatted markdown. Verdict at the top, critical issues, warning, suggestions, everything is clean and structured. Now let's talk about the numbers because this is really important. Read input 0 tokens, no AI calls. Analyze node about 1.3k tokens, roughly 2 minutes. Check quality around 1.2k tokens, around 30 seconds, which is much faster. Then the final answer block around 1.8 tokens, about a minute and a half. So all in roughly around 4000 tokens under 4 minutes total. And if you remember from the previous video, Claude Code agent took around 19 minutes to do the same thing. So this is significantly faster, and on top of that it caught all the bugs. So when it comes to the token usage, we are talking 5x fewer tokens compared to the Claude Code, around 24,000, which is a huge difference. Now to completely honest with you, Claude Code is still a better tool for the full agent loop. Reading files, writing fixes directly, running the shell commands. It got like 15 tools built in. Our agent here just analyze and report. But the point is, now you can actually understand what is happening behind the scene. It's the same pattern, nodes, decision and loops. Claude Code just have more tools plugged in. All the code related to this video are updated on my GitHub page. I'll put the link in the comment section. If you want to take this even further, you can start adding more tools like file reading, report generation, web search. Each tool is literally just a function and a node. The pattern never changes. So that's a full setup. I put a lot of time into this live test and actual logs so that you can get the real story, not just a polished demo. If you got a value from this one, hit the like button and share with the community. Thanks for being here. I will see you on the next one. Take care.